Okay, here is part 2 to part 1 of photosynthesis. Now that we know the players, ATP and NADPH, and their two alternate versions, NADP plus and ADP, there's a lot of letters you're going to have to get over. We need to know where all this is going on and what specifically is happening. So if this is a chloroplast, we have the thylakoids. Remember, little poker chips? And a stack of them is called a grana or granum, and one of these is a thylakoid. Well, inside of the thylakoid membrane, there are little water balloons full of pigment. We call those photosystems. So right here, photosystem. So there's one, let me get a different color. There's a photosystem, and there's a photosystem. Notice I've got names right here. Now this paper you have in your classwork pack. It's the very last page. So I don't want you to have to draw all this out. It's helpful if you do, but I just figured it'd be easier that way. Okay, so the steps of part 1, it all begins with sunlight. This is why it's called the light reaction, because it needs sunlight. Get this. So here's what's going to happen. Sunlight is going to travel down from the sun in the form of photons. A photon is just a little packet of energy. Now, what we see when sunlight hits us, it looks like it's just light, but it's actually little packets, but they move so fast that our eyes don't perceive them as little packets, but it's just one streaming light. So the sunlight carries these little photons, and these photons are packed full of energy. And it's the energy in the photons which provide the energy needed to make this whole process go. So step 1, light is absorbed by the chlorophyll pigments in photosystem 2. Okay, why is 2 first? Because that one got discovered second. Photosystem 1 got discovered first. Photosystem 2 got discovered second, even though it comes first in the procedure. Okay, so the photons come down from the sun, and they are full of energy. And inside of here is chlorophyll. I can spell. Chlorophyll, as you guys know, was a green pigment that we found inside of leaves. And it's in that chlorophyll where all this magic is happening. So the chlorophyll molecules have little electrons floating around them. And when the photons of light come into the photosystem, they basically bombard all the chlorophyll with all their energy. And so there's like a little energy party going on inside of the photosystem. Woohoo! Big old party. Okay? So that's the first thing. Light gets absorbed by the chlorophyll pigments in photosystem 2 in the thylakoid membrane. Alright. So, so I'm going to put boxes around each of these so you can kind of follow along as we go. So photons come in and get absorbed. I kind of think of photosystems as little sponges. Little energy sponges. They love to absorb energy. So I like to think of them as energy sponges. Okay, so now what? I've absorbed the sunlight. Great. Now what? Step 2. Electrons get excited. Yes, that is the real term we use. What that means is that in an atom, we have the nucleus, and then we have electrons that flow in rings around them. Well, sometimes electrons, if they get zapped by energy, they get so excited they jump up to higher levels. And, because, atoms have all these rings around it. So when electrons jump up to higher energy levels, we call them excited. Okay, but they get so excited they literally jump out of the chlorophyll molecule. They can't take it anymore. So in here I had the chlorophyll, and I got these electrons. They got so excited they left the molecule and jumped out of the photosystem. They just left. Said, I can't take it in here. It's too much. I gotta go. So 2 electrons get excited and jump out of the chlorophyll molecule, and then they take a ride on the electron transport chain, also known as the ETC. And here it is right here, the electron transport chain. It's very similar to a conveyor belt is how I think about it. So here's my electrons, and they're like, yeehaw, and they take off, and they're going for a ride on the conveyor belt. Now notice this is in between the thylakoid membrane. So the thylakoid membrane is a phospholipid bilayer, just like the cell membrane is. Okay, so let's take a look. So step 1, photons come in, they zap the chlorophyll inside of the photosystem. They get so excited, two of them jump ship and take a ride on the electron transport chain. Okay? So far so good? Okay, good, because we're just getting started. Next thing, the electrons. Remember, these electrons are full of energy. And so as they are going through the chain, we put some of that energy to use. And some of that energy gets used to take hydrogen ions, H pluses, and they take these guys and they shove them from out here in the stroma. And if you follow this arrow, we could see we're packing them inside the thylakoid. So here's a thylakoid, here's my hydrogen ions, and I'm packing them tight inside of here. So my thylakoid is now starting to get a little crowded inside. It's kind of like trying to stuff too many people in an elevator. So the energy that the electrons are giving off, so blah, 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 energy, energy, energy. All this energy is being used to take hydrogen ions, which are just kind of chilling in the stroma. You know, the fluid that the inside of the chloroplast. They're just kind of hanging out in there. Well, now they're getting shoved inside of the thylakoid, and we're starting to pack it tight. Okay, so that's the third step. So, photons come in, two electrons get excited, they jump ship, they take a ride down the electron transport chain, all the while providing energy to start shoving hydrogen ions into the middle of the thylakoid. Next, 4. The electrons get dumped off into photosystem 1. So remember, my electrons are riding the train. Right here, they get dumped into photosystem 1, which comes second. Okay, remember that. 2 comes first, 1 comes second. Okay, so these electrons, which were here and hopped out of here, now go inside of here. So now they're just kind of hanging out in here. Okay, so now what's happening? Well, at the same exact time that they get inside of here, hey, there's more sunlight coming down. So the next step, I lied. Food for thought. If the electrons are leaving this guy, I'm now short 2 electrons, right? I need to replace them, because if I keep giving away electrons and I don't fill them back up, eventually I run out of electrons. So I need someone to give me some more to fill them up. Well, this is why we water our plants. So this is why water is one of the ingredients of photosynthesis, because water needs to be split. So remember, photons of light has energy. So if I take my water and I can zap it with electricity, I can get 3 things: electrons, oxygen, and hydrogen ions. So the splitting of water produces oxygen. Where does the oxygen go? Out of the plant for us to breathe. Where do the electrons go? They fill in the empty spots by the 2 that took off. Where do the hydrogen ions go? They get to hang out in here with all the other ones that are getting shoved inside of the thylakoid. Okay? So, if we didn't water our plants, we would eventually run out of electrons and photosynthesis would stop. This is why we water our plants, and this is also why we like plants, because they give us oxygen. Yay, go plants. Okay, so where does each part go? Like I just said, oxygen, right there, goes out of the plant so we can breathe it. The hydrogen ions just kind of hang out in here inside of the thylakoid. The electrons go fill in the ones that jumped out earlier during the first part of photosynthesis. Okay, so now that's all taken care of. So now what do we do now that my electrons are over here? Well, while all this is happening, photons are still shining down at those 2 electrons that got dumped in. Remember, they jumped out here, went for a ride, now they're here. Now what? Well, what happened the first time? They got so excited they left. So these 2 electrons are going to get excited again, and they're going to jump out and go for another ride on the another electron transport chain. So here's my electron transport chain right here. So I got 2 conveyor belts. This one's a little shorter than this one. So those 2 electrons get zapped by sunlight again. They get so excited they take off, go for a ride on the electron transport chain again. So they started here. The photons excited them. They jumped off. They went for a ride. And now they're here. Oh, yay. Oh, no. Here comes more sunlight. Whee! They jump out and go for another ride. All right. Next. At the end of the chain, so I fall off the conveyor belt, they're literally going to fall off the floor, onto the floor. So we need someone there to pick them up, like a big catcher's mitt, ready to pick them up as they fall off the conveyor belt. Well, that's where my boat comes in. Here's my boat. Remember my empty boat? Kind of looks like this. My empty boat, NADP+. He's just hanging out, waiting for some electrons. And he says, here, I'll take you. So when these electrons fall off of the conveyor belt, they land inside of the boat, NADP+. And then the boat's very nice and says, hey, you hydrogens, here, jump in. I'll take you for a ride too. So the NADP+ picks up electrons and some hydrogens, and what does that do is it turns them into NADPH, which is my full boat full of electrons. Okay, so now what are they going to do? So I've got here's my boat. So here's my empty boat right there. He picks up 2 passengers, electrons and hydrogens, gets into the boat. Once he picks up his passengers, he becomes NADPH, and now he's ready to go do some work. We'll find out what he does in a minute. Okay, what about all these hydrogens that are just hanging out inside of the thylakoid? What are they going to do now? Well, if they don't go anywhere, the thylakoid's eventually going to explode, and that would be bad for the plant. So, thank you. So we need to get them back out to the other side. So what they're going to do is they're going to do a little bit of diffusion. We know that diffusion means things moving from high to low, concentration without the use of any energy. Since there's so many hydrogens hanging out in here, they just naturally want to flow through a hole to the other side. Well, what kind of protein is this that makes a hole? A channel protein. Okay? We learned that last unit, that a little protein that has a hole in the middle for things to go through is a channel protein. So all these little hydrogens find this hole and say, here, let me just slide right through there. As it goes through, my protein actually spins like a water wheel. And we know that we can use water wheels to produce energy. Well, as he spins, he produces enough energy to take ADP, 2 phosphates, and a phosphate that just happens to be floating around inside of there, and glue them together to make ATP. Yay! Now we have our charged up cell phone. We've got ATP, which is full of energy, ready to do its job. So, what do I do with this charged up ATP and this charged up boat full of passengers in NADPH? We are going to send them to, oh, you can't see the picture. Hold on, I need to move something. I'm going to scoot that and scoot. There we go. Okay, let's try that again, sorry. Okay, so as the hydrogen ions get pumped through, it spins the enzyme, like I was just saying, providing it with enough energy to take an ADP and a phosphate and glue it together to make ATP. Okay, now that that happens, what am I going to do with all these charged up molecules? I'm going to send them to the dark reaction, which is not in your frame of view. I really need to fix this. There we go. So these guys are full of energy now. So I'm going to take them and send them on over to the dark reaction where they can provide the energy needed to get that process going. So energized ATP and NADPH moves on to the dark reaction, which occurs in the stroma, which is the fluid in the chloroplast that surrounds the thylakoids. Blah. So, what's the point of all this? Okay, well, let's take a look. The light reaction has a couple of ingredients. We need energy. That comes from the sun. We need water. Why? So we can split it to make the electrons, and the oxygen and the hydrogen ions. Why do we need ADP? To make ATP. And we need NADP+. Why? To make NADPH. Okay, so these are all my ingredients, the things that go into the light reaction. What do I get out of it? Well, we get oxygen, which came from the water, the splitting of the water. We get ATP, which is high energy. That's an arrow, that means high. And we have NADPH, which is also high energy. Now this guy's going to leave, oxygen's going to leave the plant, but these two guys, they're going to head on over to the dark reaction. So this right here is a wonderful, wonderful picture. Hint, hint, write this down, because it shows all your ingredients, all your products, everything you need for the whole entire process. So here's part 1, the light reaction, part 2, the dark reaction. Shows you anything going in is an ingredient for that particular section, anything coming out is a product for that particular section. This, if you memorize just this picture alone, you can answer like half of the questions on a quiz or a test, okay? So, good picture to know. Wink, wink, nudge, nudge, say no more, okay? Okay, so, this is difficult. You may want to, after you write everything down, just go back and just watch and listen this time without writing. You know, have everything written down, but then just go back and listen. And then take your picture in your packet and explain it to somebody else. Tell me where things are going and what's happening, all that stuff. If you cannot explain it to somebody else, you don't know it. So if you practice over and over and over again, you'll get in the habit of explaining it so well that on the test you can explain it to yourself and should hopefully make you do better. Okay? So go practice this. It is really, really difficult. Okay? I don't want you to do bad. Go practice. Bye-bye.